Good evening, everyone. Is it audible? So let me share the link. Good evening, Shivu. Is it audible? Is it audible? Can you make it confirm, please? Okay, fair. So we'll start the lecture just after 1 minute. Let me share the link with others so that they can join. Okay, Krishuk Day. Sure. So in one problem, like some students asked for the doubt, right? So although I discussed that doubt over the Telegram group itself, so persons who still have the doubt, they are suggested to go through the Telegram group discussion as well. Okay. Only one term was missed in that example 9, I guess, right now. All are there. So let's start our lecture out now. Huh? So you people have any doubt from the previous lecture? Or I should start the fresh one now? Okay. So let me start from the lecture 2. Okay. So today we are gonna learn some more category of integrations. So when I talk about definite integrals, what happens from this property? Okay, Shivu. What happens basically is कि when you deal different type of integrations, then you encounter some basic properties there. ठीक है? So out of those basic properties, usually in the exam they ask some questions. But if you are not practiced enough, if you are not aligned with that those properties in a sequential manner, it is tough to handle those. Fair. So today again, it will be just a like not a like hard session. It will be very light session. You people are suggested to follow word by word, write down each word so that everything is aligned at one place. Fair. Chale. So those are some basic properties. Based on that, we will try to solve some questions. So if you talk about definite integral ka properties, so basically you want to a to b, suppose that a and b are some finite numbers. So a to b f of x dx, this can be written as minus b to a f of x dx. The second property, a to b f of x dx, can be written as a to c f of x dx plus c to b f of x dx, where c is a number between a and b. Fair. I talk about the other property, and that is some important property here that can be written as let's say this is the property 0 to a. So this is the same as f of a minus x dx. Means if you replace the variable by the upper limit minus that variable, the definite integral remains same. The next property is moreover symmetric with the above one itself, and that is a to b f of a plus b minus x dx. The very important property, okay? Number first is, fifth is 0 to 2a f of x dx. This will give you 0 to a f of 2 times 0 to a f of x dx if f of 2a minus x is f of x. The next property is minus a to a f of x dx. It has two possible values. Number first is 2 times 0 to a f of x dx if f of minus x equals f of x, and it becomes 0 if f of minus x equals minus f of x. So yes, many of you may think ki, sir, these are very basic properties which we all know. Yes, I know, you all know. Okay. But how to use these properties to solve those PYQs? है ना? That is the important task. So please write down all properties fast. Please note down all properties. Then I will take some examples. ठीक है? Let's take an example. Find the value of pi by 6 to pi by 3 square root of 10x plus square root of 10x plus square root of cot x dx. Okay, dear fellows. So suppose that you have to integrate this value. Now, tell me, please try it because these are basic questions, na? Try this question, please, everyone. Please try this question. Chale. Let me do it for you. देखिए how to solve such questions, how to think. If you if you think there are some 1,000 properties, you may feel the burden, right? If you think there are certain properties, if I have the image of these 6 properties in my mind, then I can verify what can be used here. So if you observe, this has a beautiful property. If you add this and this, you got a good number, that is pi by 2. Are you getting that? So how to solve it? Let I equals fair. So if I is this, what I do, I use the property 4. Okay. So I will remain same, pi by 6 to pi by 3. This will be 10 of pi by 6 plus pi by 3 minus x. Okay. The same I'll do here. 10 of pi by 6 plus pi by 3 minus 6 plus under root cot of pi by 6 plus pi by 3 minus x dx. Right, dear fellows? Can you tell me what is this? Is pi by 2 minus x. So 10 pi by 2 minus x is what? Cot x, right? So this gives you pi by 6 to pi by 3 square root of cot x divided by square root of cot x plus square root of 10x dx. So if I add 1 and 2, what I'll do? Adding 1 and 2. What you will be getting? 2i equals pi by 6 to pi by 3 under root 10x plus under root cot x divided by under root 10x plus under root cot x. So you will get just simply 1, and this will give you pi by 3 minus pi by 6. So this will be what? 3 to the 6. That is 2 pi minus pi, that is pi by 6, right? So this is how, अभी क्या होगा, I का वैल्यू क्या हो जाएगा, pi pi by 18, okay, right? So I equals pi by 36, right? So although these properties looks pretty easy, but where to use and how to use, that is the important game. Okay, please note down. So you can write here using property 4. Good evening, Pooja. Why you are late today? On an average, class is started at 9 p.m. Okay, please note down fast, everyone. Arey, what I did? 2 pi. Sorry, sorry. This is 6 only. Right? 12. Sorry, just a number. Okay. Network issue. Okay. Get the Wi-Fi. Okay. Because I'm not taking any fee, but trying to teach the quality yesterday. Like, anyways, write down all the things. Okay, Shivu. Fair. Or what about others? Everyone noted? Where is Amit Kumar today? Ramanuj, Prakhar. Should I remove this? Okay. Okay, Kishuk Day. Fair. Let's take one more example. Can you tell me what is the value of pi by 6 to pi by 3 cube root of, what it is, cube root of sin x divided by cube root of sin x plus cube root of cos x dx. What is the answer? Just 1 minute answer, right? अभी क्या है? Let I is this. So I will remain pi by 6 to pi by 3. Again, pi by 6 plus pi by 3 minus x using the property 4, right? So this will become cos x. This will become cos x. This will become sin x dx. On adding 1 and 2, we will get 2y equals pi by 6. This implies pi equals pi by 12. As simple as possible, right? Chale. So this is the very beautiful property. So please don't ignore this property, okay? Let's have some more examples now. Evaluate 0 to 2 pi modulus of sin x dx. Can anyone tell me the answer for this question? Please try this question. Anyone? No? Chale. Now see how good you are in the integrations, right? And still many people escape this part कि सर ये वाला तो मुझे आता है ना? Anyways, अभी देखिएगा what are the properties kings day 4 yes fair चले what about others okay so what I told you what are the properties we people have 0 to 2a f of x dx it becomes 2 times 0 to a f of x dx if f of 2a minus x is f of x right dear fellows. So if I ask you, what about this limit 0 से 2 pi? So since f of x is what? Modulus of sin x here. And f of, so f of 2 pi minus x will be modulus of sin 2 pi minus x. That is modulus of sin x. And ultimately it comes out as sin x. Right? So what you can do as so if I take I equals 0 to 2 pi modulus of sin x dx, can I write it like 0 to 2 pi modulus of sin x dx? Yes or no? Please say yes or no. Because I know, while taking offline lectures, I faced many students, they even don't realize what we are doing here. Okay, Amit Kadam. What about others? Please note down everyone. And I suggest you guys here, please don't be overconfident in such integrations. Just learn what properties can be useful there. Acha, can anyone tell me why I have taken negative here? Sine will be a negative function in the fourth quadrant, right? So this is the negative sign attached here, right? Chale. I guess it's done, right? Let's take one more example here. Let's see how it works. आप लोग इसको नोट कर लीजिए, आई विल नोट इट डाउन राइट. Okay, the next example is minus a to a f of x upon 1 plus e raised to the power ax dx equals to I, and f of x is an even function, then what is the value of I? Please, everyone will try. अच्छा, चलिए. Shibu has asked one question, so it's my prime duty to explain that. Shibu, when you talk about modulus of f of x, suppose that you have modulus function. This we have already discussed in the differential calculus, but again I am discussing here. Modulus x is defined as plus ka x. If x is greater than 0, this function comes out as minus ka x if x is less than 0. So when I talk about modulus of sin x, if you observe the graph of sin x, how it will be looking like? Okay, Shibu. So means here this is the f of x ka positive and f of x is negative for this. Means 0 se pi by 2 mein this function takes the value like this and then take the value negative. Fair, Shibu? So this modulus of sin x will be plus ka sin x when x less than pi by 2 but greater than 0. But f of x takes the negative value when x is greater than pi by 2 and less than pi. Sibu, is that clear now? Everyone, modulus function ka properties are clear or not? This is a modulus function which comes out as positive if this number is positive, if it comes out as negative if this is negative, right? So modulus of sin x will be opened like this. Is that clear now, Shibu? Please make it confirm. I'll be a bit slow in starting lectures, okay? So that we can cop up with each other. Okay, fair. Let's come on this question now. Have you noted this, everyone? Chale. What about this question? What they said, कि f of x is an even function, right? So if f of x is an even function, what I can do, please observe what is the definite integral here, minus a to a. So minus a to a में we observe the integrand. If this integrand works like p of minus x equals p of x, then we will have 2 times 0 to a, otherwise 0. So if I observe this p of x equals f of x upon 1 plus e raised to the power x. ठीक है? Please observe very carefully. P of minus x will be what? F of minus x plus 1 plus e raised to the power minus x. What f of x is given? Is an even function. So f of minus x is what? F of x. This can be written as 1 plus 1 upon e raised to the power x. So this will be e raised to the power x into f of x upon 1 plus e raised to the power x. So if you observe this integrand p of x and p of minus x, right? So can you say p of minus x equals to p of x? Not. So what to do here now? Anyone? Please attend this problem. Whoever will do the problem, I will send you a chocolate online, okay? चलिए. What I can do here, let if I equals minus a to a f of x, okay? So if I do I equals minus a to a, if I put p of minus x, so x की जगह if I put, okay, देखना. Can we write like this? Right? So this is just a variable. If I again use the property minus of this limit, if I change the limit again, minus a to a, right? So what will be this? No, no, f of minus. But just wait a minute. Actually, this will be e raised to the power. If I observe this, e raised to the power by, right? So e raised to the power x. एक मिनट, just wait a minute. Maybe I may be confused here. Just I am changing the variable. So if I add this, just give me one minute, please, so that I can be sure about the things. No, no, there is an issue with the problem. Just wait a minute. I'm not getting actually what the. No, no. There should be a condition over f of x, otherwise we cannot evaluate here. F of x is an even function, but end of the part it will be f of x, right? F of x पे रहना चाहिए minus a to a. This will be f of x dx. So this will be 2 times. Okay, so if f of x is not given to you, then the answer will be in the shape of f of x. If f of x moreover given more precisely, तो हम f of x we will be using there. Please note down. Is that noted, everyone? One thing I would like to tell you here, सर एक बार repeat. अरे यार शिबू अभी तो हट गया. चलो no problem. End of the day, end of the lecture, I'll do it. Again, I will say if any of the question, if you face problem, okay, कि अभी रह गया कुछ करके, so I'll repeat it in the Telegram group itself. For any issue, we will discuss there. I just have only one thing to say. Don't stuck over any particular problem. ठीक है? One more property we can have here of the definite integral, that is 0 to nt f of x dx equals n times 0 to t f of x dx if f of x is a periodic function with the period t. Okay, Shivu? Chale. So how to use this property, how they can ask the questions over this? Let's take an example here. So what is the example you can have here? Let's say they asked find 0 to 40 pi modulus of sin x dx, right? So what the function you have, dear fellows, here? That is modulus of sin x. So what is the period of this function? You can write this 20 into 2 pi modulus of sin x dx. So this can be written as, or you can type from the pi itself, because this is a modulus function. So this can be written as 40 times 0 to pi sin x dx. So 40 times sin x का differentiation minus का cos x, it is 0 to pi. So this will be 40 times minus cos pi, that is plus का 1 minus plus का 1, right? So that is 80. Fair? So such small questions can make a trouble for you. Okay? If you don't remember properties exactly, then you may shuffle कि यार अभी क्या करना है करके, right? Please note down fast. So let's take one more example for us here, that is 0 to 10 greatest integer function dx. Shibu, sin x का period is 2 pi. Okay, Shibu? Because sin 2 pi plus x, f of t plus x. Periodic means after that particular interval function repeats its nature, its behavior. So let's say if you want to integrate this, this is the greatest integer function. Greatest integer function, right? This is written as x minus fractional part in x. What it is here is fractional part in x. For example, if you want to find what is the greatest integer of 4.5, it will be x minus fractional part इसके अंदर कितना है 0.5, right? So that will be 4. For example, if you want to write what is the greatest integer of minus 4.5, so it will be, formula is this only, okay? X minus fractional part, greatest integer x is this. So this will be, tell me what is this. So when you are dealing with the greatest integer function, these are some basic words which you are supposed to remember, right? अभी क्या है, आसान हो गया. So this is the periodic function with the period 1. So what you can say here, dear fellows, since greatest integer x is a periodic function, right? Abhi, so what do you want to, so 0 to 10 greatest integer x dx, that can be written as 0 to 10 x minus fractional part of x dx, right? So that will be x square by 2 from 0 to 10 minus 10 times 0 to 1 fractional part of x dx, right? So that will become 50 minus 10 into 0 to 1. Let me connect the battery, please. Sorry. So अभी देखेंगे, many people may confuse here 0 to 1. If you please ध्यान से देखना, if you take a number between 0 to 1, between I am saying, so that number will come as outside. Fractional part of x for 0 to 1 is nothing but x itself. Am I clear to you all? So this will become 50 minus, this is x square by 2, so 1 by 2, that comes out as 45. So you can write here is, if you observe what is the fractional part on 0.2, that is 0.2, right? What is the fractional part in 0.9, that is 0.9. So any number that will come out as x if x is less than 0, less than 1 and greater than 0. So fractional part of x will come out as x if x is lying between 0 and 1. So this is one more beautiful question for you. Please note down. Again, I will say these problems may look very easy, but for you, you are not aligned, you cannot solve these problems. Note down fast, please. And if any doubt, then please let me know. Oh, sorry. I'm sorry. Please write down this fractional part. Please observe here. I have edited the bit. So please write down this statement. Is that done? Make it confirm, please. Okay, Shundaram. Fair. One more beautiful problem I would like to discuss here. UPSC also asked that 2-3 times. Okay. Very standard but very easy. So let's take one more example here. Find the value of 0 to pi log sin x dx. Yes, Shibu. Yes. Fractional part function is a periodic function. Okay. फ्रैक्शनल पार्ट क्या है? वो आप चाहे तो 0 से 1 के बीच में इग्नोर भी कर सकते हैं. यू कैन इग्नोर दैट. Fractional part means what? It will always be a value between 0 and 1. क्या डाउट है आपका? बोल तो रहा हूं शिवू. Shibu, did you get my point? Let's come here. शिबू, आपका लेक्चर थोड़ा लैग कर रहा है क्या? रिफ्रेश योर लेक्चर यार प्लीज, है ना? So how to solve this problem? Let I equals 0 to pi log sin x dx. ठीक है? So what we have studied, the basic property of definite integral 0 to pi by 2, it can be written as log of sin x dx. Why? Because log of sin 2 pi minus क्या है? Pi minus x, sorry. It is log of sin x, right? So since f of 2a minus x is same as that, so what I have here, I equals 2 times 0 to pi by 2. ठीक है बच्चे, log of, अभी क्या करेंगे, साइन, आई एम यूजिंग अगेन द प्रॉपर्टी sin pi by 2 minus x. So this will become 0 to pi by 2 log of cos x dx. So if I add this and this, what will happen? Adding 1 and 2, what I'll be getting, 2i equals 4 times 0 to pi by 2 log of, क्या बन जाएगा, sin x plus log of cos x dx. So if you observe here, this can be written as, this 4 is here, so I by 2 equals 0 to pi by 2 log of sin x, because log m plus log n is what, log m into n, right? So this is equal, is the same problem with everyone? Is the video lagging for everyone? Network issue from my side or yours? Please make it confirm, everyone. The lag in the video from my side or yours? So this I equals 0 to pi by 2. What I can do, log of sin x, 2 sin x cos x divided by 2, 2 से मल्टीप्लाई कर दिया, 2 से डिवाइड कर दिया. This can be written as 0 to pi by 2 log sin 2x dx minus 0 से pi by 2 log 2 dx. If you put 2x equals to t here, so this will be turned to 0 to pi by 2 log sin t dt, that is 1 by 2. ये क्या हो रहा है, 0 to pi by 2 एक मिनट रुकेंगे. अच्छा 2 to 4 कहाँ हो गया, आई एम सॉरी, दैट इज 2 ओनली ना, so that is I. 2 is taken as common, right? 2 plus 2, so 2 will be out. So 1 upon 2 minus, this is pi by 2 log 2. This is what, my dear fellows? Tell me. इधर में चल रहा है I. So this is I equals 1 upon 2 minus pi by 2 log 2. Please clear, sir, no network issue. Okay, Shundram. Then बाकी लोग, Sibu, please check your network. From my side, it is very much clear. So this line I would like to write here. So I equals 1 upon 2i minus pi by 2 log 2. So if you take this I by 2 in this side, so you got minus pi log 2. Please note down, this is a good problem. UPSC asked this as well. So 0 से pi log sin x, 0 से pi log cos x, the result will be same. Okay. So this is a very famous problem. You can write down this in a separate box so that it is in your head, right? Have you written this? Kingshuk Day. Fine. Okay. Please note down everyone. Shundaram, is that noted? Have you written it? Okay, fair. So I guess how to use basic properties of definite integral, that will be clear to you all now. Okay, Pooja, fair. So Abhi, we will be doing some reduction formula as well. Again, I would like to tell you, no one is going to ask you reduction formulas, but those can give you a hint how to proceed some particular integrals. Okay. So whenever you have some integrations like, so the next subtopic here is reduction formula. Okay. So, what is the intention behind those? For that, I would like to tell you. For example, if you want to know what is sine cube x, okay, the limit may be anything. I am out of the definite property integrals. Okay, abhi we are again on the another subtopic. So, if you have some integration like this, how to deal such integrations when you have some higher powers over the functions, trigonometric especially. So we will manage this as, suppose that sine square x into sin x dx. Fair. अभी sin square x को how to handle, that we need to learn here. Whenever you have sine square x or cos square x, we will always replace that with cos 2x. So this can be written as 1 minus cos 2x divided by 2 into sin x dx. I am just giving you from where the intuition comes for reduction formulas. Okay. So this can be written as 1 by 2 sin x minus 1 by 2 cos 2x into sin x dx. Right. Abhi, what you can do here, this is minus का 1 by 2 cos x. This is minus का 1 by 2. Fair. Now, I would like to tell you one thing here. What happens now? What to do next? Again, I will say, for reduction formulas, it is not necessary you will get the final conclusion as some number. You may have some relation as well. Okay? So for such integrations, how to deal such integrations, for that we have reduction formulas. So now I'm gonna write those reduction formulas very fast. You people are supposed to note down those, so that those are in your revision notes. Okay. चलिए, so number one is in equals let's say if you want to calculate 0 to pi by 2 sine nx dx, where n is some natural number, means n is running from 1 to 3 onwards, right? Check. So how to deal these things? Again the logic I told you guys, sine n minus 1 x into sin x dx. Now we will apply first into second का integration. So that is minus का cos x 0 to pi by 2. So इसका integration, that is minus का cos x, right, from 0 to pi by 2 differentiation of, so n minus 1 sin n minus 2 into sin x का differentiation cos x dx. Fair dear fellows? अभी cos pi by 2 is 0, cos 0 is 1. So ultimately we will have minus का cos x, that will come out here, into sin n minus 1, ये पूरा लिमिट है, राइट? सो एक बार में साइन 0 0 देगा, पूरा टर्म 0 हो जाएगा, राइट? अल्टीमेटली वी विल हैव, तो वहां का n माइनस 1 विल कम आउटसाइड, that is 0 to pi by 2 sin n minus 2x, this will become cos square x dx, right? इधर में क्या चल रहा है, लेट्स रिप्रेजेंट इट in. So in will be n minus 1 0 to pi by 2 sin n minus 2, this can be written as 1 minus sin square x dx, right? Abhi what I can have from here, n minus 1 0 to pi by 2 sin square x यहां पर मल्टीप्लाई करेंगे, we will have sin nx dx, so that will be minus ka and plus ka, this will be 0 to pi by 2, n minus 1 is multiplied sin का power n minus 2x dx. So this is what, my dear fellows, that is in again, right? So you can manage this in to this side, and this will give some another respective relation. So what I can have from here is in equals n minus 1 upon n into in minus 2. So this is just a glimpse for you guys कि what are reduction formulas all about. Please note down, everyone. क्या रिपीट करना है शिबू? What I shared you here is कि whenever you have integrations as trigonometric functions का power, what you can think of is, okay Shibu? So for like to which destination I will try to reach here. That is my task. Although I can like expand more, but I put question mark here. From here I said that this gives an intuition that we should have some general formulas for such functions का integration. ठीक है शिबू? So I took if integration like this where this is sine nx, right, power nx. So this I represented by in. So whenever you have some reduction formula, you will manage this integrand in the manner so that you can have some function for which the differentiation you know or integration you know. So sin x ka integration we know. So we managed this sin nx as this. After this we applied integration by parts here. Okay, Shibu? So when you applied integration by parts here, you got the relation because this term cos pi by 2 पर 0 होगा और sin 0 पर 0 होगा. So this whole integral will give you 0 value, right? So this becomes 0. Ultimately, we have this only. So for this expression, I have written this cos square x as 1 minus sin square x so that I can get something related with the given integration. Okay, Shibu? So I have the relations like this. So sin square x का यहाँ multiply करेंगे, we will have this expression. And this is sin n minus 2. So for this I have done n minus 1 into in. Abhi this in ko you will come here. So this will become n into in, right? So n into in का in यहाँ पे रखा, n will be in the denominator. This is n minus 1 upon n. This is 0 to pi by 2 sin n minus 2x dx. So if in is this, so this can be written as in minus 2 because the power is n minus 2. Okay, Shibu? Is that clear now? Reduction formulas. One more formula I will take. It will be more clear to you all. Okay. So did you guys written it? Have you written it? Okay, King Shuk Day. Okay, Shibu, fair. Let's take one more example here. Acha, one just a request from you guys. Actually, I'm in my hometown, not in Delhi. So just थोड़ा सा बिजी हूँ. आई एम बिट बिजी फॉर नेक्स्ट 2-3 days. तो प्रॉब्ली कभी कभी द लेक्चर विल बी शॉर्ट बट फ्रॉम द नेक्स्ट वीक ऑनवर्ड्स द लेक्चर्स विल बी एज पर देयर शेड्यूल. सो लेट्स से टुडे आई हैव जस्ट वन लेक्चर फॉर यू. ब्रेक के आफ्टर में देयर विल बी नो लेक्चर. सो आप लोग गुस्सा नहीं करेंगे. There are some genuine works for which I have to be engaged, but I will take some extra sessions for you to manage these times. So today we will have just one lecture. After the break we will have no lecture here. ठीक है? Tomorrow I will try to like take two lectures, but like there is a little sister for me, so okay. Little sister means my younger sister, so we have some tasks to do related with the marriage, you know. So thoda sha you will cooperate, okay. Let's take some more example here. So that is done. Mm. Next is Wally's formula. Please note down this formula. This will be very helpful. And that formula is 0 to pi by 2 sine nx dx. That is again the byproduct of Wallis, this reduction formula. That will be n minus 1, n minus 3, n minus 5, 1 by 2 into pi by 2 divided by, sorry. So if you want to know from where the Wallis formula is coming out, what you can do from reduction formulas. Okay? Although you are supposed to remember this expression directly, we will be able to use from reduction formula. What is the relation? In is n minus 1 upon in minus 2, right? In minus 2 can be written as n minus 3 upon n minus 2, in minus 4, and so on, right? So if you want to write in as n is even, n is odd, you will get this relation. Okay, dear fellows. So Wallis formula is just a byproduct of reduction formulas. Shundaram, are you getting the things? King Shukte, are you getting? Amit Kadam, where are you? Please note down this. After this, I will take one example how to use this Wallis formula, because that example is important. Okay. Please note down fast. Then I will take an example. You people, please note down this. I'm just writing an example here. Sine square theta, that is 2n plus 1, that is sine theta d theta, right? So when you change the limit, this minus will be managed here. Okay. Chale. And persons who are new to this lecture series, they are suggested to go through the description. You will come to know how to prepare in right way this mathematics optional with the GS and essay. Okay. Because यहाँ पर I cannot repeat again and again. So this is a very beautiful example or application of reduction formulas, that is Wally's formula, and over that you are asking this. Abhi, if you want to observe this, sorry, 2n plus 1, since 2n plus 1 is always odd, so why Wally's formula, you can get the value of 0 say pi by 2 sine 2n plus 1 theta, right? So what will be that value? Should I write it? Just I'm writing the value here. That will be 2 into 2n factorial divided by 2 raised to the power n. अच्छा, इसको मैं वहां पर लिख दूंगा, थोड़ा स्पेस चाहिएगा होगा मुझे. I'll just remove this part. So please observe, if you have sine raised to the power n here, then the formula is like this. If you have sine raised to the power 2n plus 1 here, the formula will be based on, so I'm writing that here. It will be whatever is outside, that is 2n factorial divided by into 2 raised to the power n, it is right. So 2 raised to the power 2n they have taken. Chalo, that will be managed. Actually, in the problem they are taking, the problem that was 2 raised to the power 2n. Please edit that. Otherwise वो जो number होगा ना, वो उतना beautiful अपने को नहीं दिखेगा. So please edit this expression, everyone. 2 raised to the power 2n it was given in the expression. So this is 2 raised to the power 2n into 2. Now we are applying Wally's formula over this 2n plus 1. So 2n plus 1 minus 1. 2n plus 1 minus 3. If n is odd, right? Divided by 2n plus 1, 2n plus 1 minus 2 dot dot 2, that is 3, right? So if you solve this expression, you are getting basically 2 into 2 raised, okay. I'm writing the expression here, 2 into 2n factorial divided by 2 raised to the power n, that is 2 raised to the power n, n minus 1, n minus 2 up to 2 divided by 2n plus 1, 2n minus 1, 2n minus 3 up to 3. So ultimately we got the things as 2 into 2n factorial divided by 2 raised to the power n, क्योंकि 2 raised to the power 2n था, 1n is cancelled from here, so this comes out as, just give me 1 minute, this will be a problem, 2n minus 2 up to 2 इसका whole square divided by 2n plus 1 into, just I'm doing the management of the terms, nothing else here. So that is 2 into 2 raised to the power 2n divided by 2 raised to the power 2n into n factorial divided by 2n plus 1. So 2 into n factorial का whole square divided by the numbers you can check out later on, but the procedure I have told you what is the application of reduction formulas. Actually I'm running short of time, so I just note down, please note down fast. Have you written it here? Abhi, you just note down, later on you can take on the like management of the terms. That is easy one. Noted? Fair. चले. अभी I have just a request. सिस्टर का मैरिज के फंक्शंस आर गोइंग ऑन, तो मेरे ऊपर बहुत सारा प्रेशर है एज आई एम द एल्डर ब्रदर. सो प्लीज कोऑपरेट फॉर नेक्स्ट जस्ट 2-3 days. आई विल टेक एक्स्ट्रा सेशंस फॉर यू इफ रिक्वायर्ड. ओके, तो टुडे एंड टुमारो and day after tomorrow probably, yes, maybe I will take 2 sessions, but 1 session definitely I will take, okay, before the break. Also today I increase the time. So the basic integrations ka formulas we have done till now. Tomorrow we will be doing special integrations like beta gamma functions. Okay, so let's stop the lecture today here. Please revise yesterday's and today's lecture. Tomorrow we will be starting the very beautiful. क्या कहना था शिबू, बोलो. शिबू जायसवाल, क्या कहना था? बोलो मेरे भाई जल्दी. टाइम को लेकर तो आप लोग परेशान मत होइए. वट एवर आई हैव शेड ना, and in the differential equation and calculus you have seen how much precise I am, how much comprehensive I am during the classes. Okay, so don't think syllabus hoga ki nahi hoga. Syllabus will be covered as per the time, October last. Okay, don't bother about the things. नहीं तो 23 वाले लोगों से पूछ लेना सिलेबस हुआ कि नहीं हुआ, है ना. शिबू यार जल्दी बोलो, तुम्हारा नेटवर्क लैग कर रहा है. हाँ, मैं आपका समझ गया था, आपकी प्रॉब्लम को मैंने उसका रिप्लाई पहले कर दिया है ना. अरे भाई आप लोग इतना परेशान क्यों हो जाते हैं? इनिशियली भी मैं चाहता तो लेक्चर आपको 1-1 घंटे का कर सकता था, बट नहीं किया ना. प्रॉपरली ऑफलाइन लेक्चर्स की टाइप से लेके चल रहा हूं, तो थोड़ा तो विश्वास रखो भाई, क्योंकि आई एम नॉट अ कंप्यूटर और सुपर ह्यूमन की जो बोल दिया वैसे ही चलेगा. वी आर ह्यूमन बींग्स लाइक शिबू. तो थोड़ा सा कभी क्लास ज्यादा भी हो जाता है, कभी कम भी हो जाता है, बट हाँ वन थिंग इज श्योर कि सिलेबस टाइम पे होगा एंड वेरी कॉम्प्रिहेंसिव अकॉर्डिंग टू डिमांड ऑफ सीएससी एंड फॉरेस्ट सर्विसेज होगा. ठीक है. सो डोंट बॉदर प्लीज, आई रिक्वेस्ट यू गाइस, क्योंकि नॉर्मली जब वेन एवर आई एम इन दिल्ली देर इज नो इशू सच, बट आई एम इन होम टाउन, देर आर सम सोशल रिस्पॉन्सिबिलिटीज एज वेल. सो आई डोंट वॉन्ट टू लाइक स्विच ऑफ द क्लासेस कंप्लीटली. आई एम टेकिंग वन सेशन फॉर यू. ठीक है. और कल को होगा तो दो सेशन भी ले लूंगा, कोई इश्यू नहीं है उसमें. ठीक है. So let's meet by tomorrow. Thank you for the cooperation. Don't skip classes. Stick to the classes. Be disciplined. You will learn everything here. Good luck. Good luck. Please cooperate. Please cooperate. Good night, everyone. If you want to talk to me, you can talk over my number.